Here we want to find the derivative of 1 over a times tangent inverse of x over a, where a is a constant. And so recall that the derivative of tangent inverse of x is 1 over 1 plus x squared. And so the derivative of 1 over a times tangent inverse x over a, since 1 over 8 is constant, then we can move it and place it in front of the derivative here. And then x over a is the same as 1 over a times x. And so using the chain rule, so here we have the constant 1 over a, and then here the derivative is tangent inverse of 1 over 8x instead of just x. And so the derivative in the place of x, we would have 1 over a times x. And then the chain rule says we have to multiply by the derivative of 1 over a times x. So once again, the derivative of tangent inverse of x is 1 over 1 plus x squared. But here we want the derivative, instead of x, we want the derivative of tangent inverse of 1 over a times x. And so in the place of x, we would have 1 over a times x. And then the chain rule says that we have to multiply by the derivative of 1 over a times x. The derivative of 1 over a times x, it is 1 over a. 1 times 1 over a, it is 1 over a. And then 1 over a times x squared, we can write it as x squared dividing by a squared. And now let's multiply the top and the bottom by a squared. So multiply the top here by a squared, multiply the bottom here by a squared. 1 over a times a squared would be just a. 1 times a squared is a squared. X squared over a squared times a squared is x squared. And then here we have 1 over a, and then here we have a. So a divided by a is just 1. A divided by a is just 1. So we end up with 1 over a squared plus x squared. And therefore the derivative of 1 over a times tangent inverse of x over a is 1 over a squared plus x squared. So the derivative of this expression is 1 over a squared plus x squared, and therefore the entire derivative of 1 over a squared plus x squared will be 1 over a times tangent inverse of x over a, and then plus c.